Okay, I hope to explain here how to graph this equation. Now, first off, let's observe what we're seeing. We're seeing a x squared equation, and I notice that there is a single x. This is the format that we're seeing, the equation, and I put some notes that we should remind ourselves of these transformations. So the first step of all of these is we are going to identify your a, h, and k. Well, the a is 3. That's the a in front. So I'm going to put a 3 here. Your h is the thing after the x. So it is a -4, a -4. And your k is a -7. You always start by identifying your a, h, and k. Next up, we have the transformations. So I'm going to look to my notes and say, what does a positive 3a value do? Well, it's not a negative a, so we can ignore that. A is a stretch if it's larger than 1, so I'm going to say that it is a vertical stretch, technically. It is a vertical stretch by 3. A lot of things going on. What does the h do? Well, a negative h moves it right by that much, right by 4. And a -7k value moves it down 7. That's the order of the equation, not the order of how we're going to graph it. The order of how we're going to graph it is these two things first. So what I'm going to do is I'm going to choose a different color. I'm feeling like purple. And I'm going to draw a line that moves from the origin, or these axes are going to move right 4. So this vertical is going to move right 4. And it's going to go, this x-axis is going to go down 7. Well, here are my new axes. And the first thing I have is a dot. I found my vertex. Now, we've done everything with this right 4, down 7. Now we need to do this vertical stretch by 3. In order to do that, we have a little trick. It's called the 1a, 3a trick. This is going up. I'm going to say above my vertex will be my 1a, and then even above that will be a 3a. Well, okay, 3 times a, 1 times a. So my a value is 3. I'm going to replace my a with a 3. You see where that came from? It came from way up here, which is also right here. And easy math. 1 times 3 is 3. 3 times 3 is 9. And that is above my axis. So that's going to help me find my next few points. So from my vertex, I'm going to go over 1, up 3. 1, 2, 3. And then from that point, I'm going to go over 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then since you have this vertical line, this is the line of reflection. With a nice curve, I'm going to connect my lines, my dots, excuse me, do my best to show that I'm aware that this is like a U shape and not a V shape. Arrows, and it's going up. All right, now that I have identified my A, H, and K, identified my transformations and my graph, I do need to name some of these points. So the most important point here is at 4, -7. And this point here is at 5, -4. And this point here is at 6, 5. And that is just so that we have these numbers here. And if your graph is unclear, we could at least see what you attempted to show us. So now let's identify some of these values here. So my vertex, we already saw, was at 4, -7. It's an ordered pair. It is the point where the axis comes together. Vertex means turning point. So my graph turns here, most important point, 4, -7. My domain, everyone's favorite, all real numbers. And my range is going to say, well, I have I'm going to put some like notes to myself. I have a min, right? I can't go any lower than this over here. I'm going to say I have a min of -7. I can't go any lower in my graph than -7. There is no -8. So I'm going to say that my y values are greater than or equal to -7. Next up, I need to name my axis of symmetry and intervals of increase and decrease. Now I'm going to draw a nice clean box over these because these are all connected. Excuse me. These three are all nicely and neatly connected. My axis of symmetry, remember, we always kind of in a silly way exaggerate. We call this the x's of symmetry because we want to encourage you to remember this is going to be an x is, otherwise known as an x equals answer. Well, remember how the y-axis shifted to the right 4, and this vertical purple line is at 4, x equals 4. Well, that cuts my graph in half. I now have a left arm and a right arm. And here we say, let's imagine there was an ant up here. I'm going to zoom in really far. All right, ready? I have an ant. Let's see how well I can draw. All right, this ant, I read from the left of my paper to the right of my paper. If this ant was all the way to the left, would he be going uphill or downhill as he started walking to the right? Well, this is a downhill, right? So that's why he's going down a hill. And then guess what? He's going to go way up. He's going to go downhill until when he hits the vertex. And then when he's down here at the vertex, is he still going down as he goes to the right? Well, no, he starts to climb up the hill. And so I can identify in my increasing, decreasing now. I can identify that, at least to show your work right, just to, for my own sake. I'm going to say he's increasing. He's going uphill to the right, and he's going downhill to the left. And so do you remember when I put a big box around this? It's because all your answers are going to include x and 4. X and 4. You know how we said it was to the right? We're going to say it is to the right of the axis of symmetry, and it's decreasing to the left of the axis of symmetry. Okay? And since I have another minute with you, we ask a couple other points. Questions. Sometimes we do ask you, what is the maximum or minimum value? Max or min value. And I kind of already named it up here. It is a min of -7. And let me expand on that just slightly. The value of the function is like a y. This is a y function, right? Y is equal to blank. That's like your function. So when it asks you for the value of the function, we're asking a y question. So you could say y of a min of y equals 7 if you'd like. We could just say y a min of 7. But you do need to know that it is a minimum. It's clearly a minimum because my vertex is a low point. It's not like a mountaintop. It's like way, way, way down in the valley. The last thing we could ask for is, what is the y-intercept? Well, the y-intercept, we have to remember, is when x equals 0. So what I could do, and what you need to do, if you can't, like, sometimes you could just point to your graph and say, oh, my graph conveniently crosses the y-axis at a certain point. In this case, that doesn't work. In this case, you actually have to go back up to my equation, and I have to say y equals 3, 0, minus 4, raised to minus 7, and then you just have to use order of operations to simplify. Inside my parentheses, -4 squared positive 16. 16 times 3, I think, is 64. Real-time fact checking, not 64, it's 48. 48 minus 7 is 41. And so I'm going to say I have a y-intercept of either you could say 41 or you could say 0, 41. And that's way off my chart. But is my arrow pointing to that? Is that kind of reasonable? Yeah, it would eventually hit this positive big number. If you got a -41, that would be a little suspect because my arrow will never get to a negative big number, right? And that's how you graph it when it's in this format. A couple quick notes coming up. I highlighted for you 3 different x squareds, 3 different quadratic functions that highlight some differences that you'll see when you're identifying your A, H, and K. So this one, we can see, has an A position, an H, and a K. So it's fairly clear to identify that, oh, okay, A is 3, K is -4, and H is -4, and K is -7. Now, we just did this example. So we know that the H and K all affect how it moves left, right, up, or down. So this moves right 4, down 7, and this one is telling me that this is a vertical stretch by 3. And what does that mean? Basically, it's saying that if this is my x, if this is my x and y, it means that, purple, I'll move it over, it goes right 4, down 7, and then the basic sketch is that it moves with your vertex here, and it goes up from there. Super basic sketch, not precise, but that's what you should see as a result of graphing this. Now let's keep going. This is one where I have an A position, but I don't have, like, something else is missing. So we have to identify what is missing. Well, whenever you see the parentheses, you have an H. Say it again. Parentheses means H. So let's identify. Your A value is this negative out front. I'm just going to call it a -1. You can just put negative, that's fine. Your H value is a +3, and your K value is a 0. So what does that mean? It means when I put these two together, it tells me how my axes are moving. So this goes left 3, and it goes up, down. It does not move up or down. Okay, so right away, without anything else, I could sketch my axes. Well, I'm going to choose purple just to be consistent. It goes left 3, up and down nothing, and so that's where it's going to be. Now then we have to ask the question, okay, well, what is this -1 doing? Well, an A value of -1 means that it is a reflection over the x-axis. Sometimes we call that a flip. I want you to remember this. If there's a -A, that's a frowny face. Let me show you what a frowny face looks like in vertex land. Not vertex land, excuse me. In parabola land, it means it goes down. All right. Next up, we have this one. Well, we clearly have a number in front of x squared, so that's my A. That's a -4. Now remember, there's something missing here, right? It's not this setup over here where I had 2 other numbers. I only have 1 other number, so I need to identify, is it an H or a K? Well, remember that parentheses means H. Is that in parentheses, that 10? No, so that must be a K. So my H in this case is 0, and my K in this case is a +10. Okay, once again, we know that these two are going to come together and tell me how I'm moving left and right. Well, I'm not moving left or right, but I am moving up 10. So if I wanted to, I could just do a basic sketch on the side of my paper. I want to post a note somewhere. It's not super important. It's not your final answer, but I should have some awareness that I'm going up 10, left and right nothing, and then my A value, importantly, is doing 2 things. The -A is doing one thing, and the 4 is doing another thing. The 4 means it stretches, and the -1 means it flips. So together, we should be aware that it's going down skinny. It's going down real fast, stretch by 4. I don't have time to type it, but this is flip, and this is stretch.